Hi, good evening, everyone. Welcome to this webinar, which is on managing materials flow using theory of constraints approach. So I want to start with a question. Is it possible for one initiative to increase sales, improve your delivery performance, uh, simultaneously have reduced inventory and also wastages, and it is to be achieved in a very short period of time without any increase in investment or operating expenses? So this is what we do at Yagna. So Yagna Entrepreneur Success Services, short for Yagna, is a boutique consulting company which is into business of enabling manufacturing companies achieve significant uh, improvement in their operations and financial performance. Hi, I am Ayush Agrawal, co-founder at Yagna. I have almost 15 years of experience in implementing theory of constraints across different organizations over different industries, and I'm a certified TOC expert. So we will be today. Who is it? Yeah, and somebody has joined.
Yeah. Nitin Songire and Sharad Shirsagar has joined. Yeah. Hi, Sharad and Nitin. Yeah.
Please welcome. We have just begun. So today's agenda is to understand how traditionally we at the companies we manage the operations, as a result of which what challenges or problems we face, uh, a simplified way of managing operations using theory of constraints approach. How can we design our system in such a way that it enables it to deliver more with reduced inventory? And more importantly, I want to spend more time in discussing the practical mechanism to enable this, because conceptually it is good to hear, but how do we practically implement it in our plant will be of utmost interest of me as well to share with you. And at the end, we can take some questions. So I'll begin with the reality of the supply chains today, because in past the supply chains were
Your presentation is not shared yet.
I'm sorry, but I shared my screen. Really sorry.
Yeah, you can come to the slide which is running.
Yeah. So this is what I prompted, that can we achieve significant sales and operations performance with reduced investment in a very short period of time, without any investment, without putting any new money, and without increasing our operating expenses. So that's what Yagna specializes in. And we have done this across different companies, across different industries. And in last 7 years of Yagna's existence, we have implemented it at many organizations. So I am Ayush Agrawal, and I'm a co-founder at Yagna. Have expertise and experience in implementing theory of constraints across organizations. So today's agenda is to predominantly quickly discuss around what is the traditional way, the way we manage operations, as a result of which what challenges the companies face, a simplified way of managing operations, and how can we design our system in such a way that it enables it to deliver more, support more sales and reduce inventory. And as I said, I want to spend more time in discussing the practical mechanism to enable this materials planning and execution, especially, which is aligned with the true market demand. And at the end, we can take a quick question answer session where I can probably answer all the questions you guys might have. So I want to start with the reality of how our supply chain is today, with which we are dealing. So in past, our supply chains were relatively simple, right? The complexity was low. The variety of products that we were dealing with was low. Customers were ready to wait. The tolerance time of the customers low, uh, were high, and now customers want it very fast. So time has shrunken. Complexity of the product itself has increased significantly. Customization is the key. Everybody wants customized product. With the pressure of from the competition, product variety is increasing. Uh, Today we know that we have tens of thousands of variety in different companies. Lead times have increased significantly, as a result of which the delivery performance, on-time delivery has gone poor. Forecast accuracy, as the variety is increasing, as the variability in the demand is increasing, the forecast accuracy has also gone pretty low. Uh, and in order to do all this, there is always a pressure to reduce inventory. We are today dealing with a lot of customers and suppliers, and it is increasing every day. And today, unlike past, we are today geographically spread. Every company has multiple locations, and many a times it is geographically at different places. So it becomes challenging to manage all the operations and entire show. So traditionally, companies have tried to handle this by adopting ERP system with the belief that if we adopt ERP, all the problems will be solved. We will be able to do it systematically. But what we have seen is in many companies, even after adopting very expensive ERP systems, ultimately the usage is reduced to only recording the transactions. Actual planning, actual working happens outside on Excel sheets. And second action that companies take is by adding more people that who will handle all this. But it makes the system more people dependent rather than system dependent. And as the companies scale, it becomes difficult to manage, and dependency on few key people increases. So the way out is that we have to do differently. We have to change our way of managing operations, our processes, as well as the system, IT system that is in place needs to be transformed. So that's the direction we want to take. So traditionally in manufacturing, the way we look at our shop floor, it's like it's a space which is occupied by different machines, right? And the way we look at is that the work move from the first operation, first resource, and it's a sequence of dependent operations that work on operation 2. Resource 2 can only start when the resource 1 has completed working. So that's how the material moves. So this we are calling it as a resource-centric view. So so I want to ask a question. So do we get bothered if have we seen the owners, the CEOs, everybody to get bothered when we see that somebody on the shop floor, some machine or some man is sitting idle on the shop floor? Maybe you can type your responses in the chat box. How often have we seen that the moment we see that machine is down or somebody is sitting idle, we see that work is happening, and we get bothered about it and decide to take some action? You can either unmute yourself and answer, or maybe I would request if you can type in the chat yes or no. That will help. Am I audible?
Yes, you are audible.
Yeah. Okay, so what we have seen most of the time is the moment we see the owners or the top management see that somebody is sitting idle, we feel that work is not happening and we should do something about it. But why this thought comes to the mind is because we feel that if all the resources are working, then only the work is happening. Otherwise, we will not be able to produce and deliver as per the customer requirement. The major assumption behind this is that in manufacturing, the primary question or the primary goal which is given as a target to the operations management is the cost control, that we must control our cost. We must ensure the way we are working so such that per unit cost is controlled. So we try to maximize our cost by ensuring that all the resources, including man, machine, everybody is busy, everybody is working. Because if somebody is not working, then that, because resources are consuming cost, right? So that is a typical way we have been fed by the cost accounting method. So resources consume cost. So if they do not work, it means we are losing money, and our cost will go up. So that's the typical assumption behind, and hence the action that our endeavor is that if we have to control cost, all our resources must operate at a highest efficiency. So efficiency is the key measure, right? So ultimately what it means is, if a resource or a machine is standing idle, it is considered as a waste. But this is the reality, right? Any manufacturing setup that we see, we will see that different processes, different work centers will have their own capacity. So I have taken an illustration that some input as a raw material starts, it gets processed at A, then B, C, D, and E. Finally, the output comes. And this is the capacity of respective work center. Work center A can make 15 units per hour. Work center B can make 12 units per hour. Work center C can make 8, D 10, and E 12. So can somebody tell me what would be the output of the system per hour? What is the output that we can expect from the system?
8 units.
Yeah, right. So we know that in this system, C is the process which has the least capacity. It means that A, B, D, and E have more capacity than C. So we call this process which is having the least capacity as a bottleneck, right? So theory of constraints says that in every system at any point of time, there is always a bottleneck which governs its capacity, or which determines the maximum a system can perform, which is called a bottleneck. And a system cannot deliver more than its bottleneck capacity. So this is the reality. Now, in this scenario, what will happen if we try to put the rule that everybody is busy and everybody continues to produce? So let's say operation which are upstream, operation A and B, if they continue to produce, because they have more capacity than the bottleneck operation C. So if they continue to produce more or at their actual capacity, what will happen is it will only lead to increase in the WIP on the shop floor. And the way now, can you see that operation D and E have more capacity on the bottleneck? So ideally, when the work gets released from bottleneck operation C, ideally it should not stop, it should run, right? But in absence of this understanding that what is the bottleneck today, what we have seen is that a lot of capacity of the bottleneck gets wasted, and the inventory generally is all over the shop floor. And then we get into this planning of every operation. Then every morning there will be a planning of A, there will be a planning at B, there will be a planning at C, there will be a planning at D and E respectively. So so this is what happens, that when we are not aware about the bottleneck, and we try to operate our resources at full capacity, so it only builds up the WIP. Now now we discussed that the primary measure that operations have is the efficiency. So I've taken an illustration for for a plant that if my primary measurement is efficiency, which ultimately means that what output I am delivering in a day, whether it can be number, tons or meters. So if that is the measure, then I will try to do everything which will maximize my output, right? So I will take all the actions. First, we know that in order to control per unit cost, in order to have more output or do more volumes, production we are compelled or forced to take production in large batches, right? Second action that we do is, because we cannot stop production, we consider it as a loss, and plus we also want to keep workers motivated. So ultimately we keep on producing even when there is no market demand in the short term. So what will happen is, whatever we are producing for a stock, it will go and sit in the inventory, right? This is one of the major phenomena that we have seen, that we have orders lined up for the customer. Now, in order to reduce setups, which also enables increase in batch size, we keep on pulling orders so that we can batch them together and uh, uh, produce, so that our efficiency remains high. So what damage it does is, ultimately the orders which are supposed to go now gets delayed, and the orders which are supposed to go later, they gets produced now and ultimately sits in the inventory. So this is the all kind of problems or symptoms that we start seeing in a company when this type of measurement or phenomena exist. So we see that inventories have gone high. We will see very high WIP. As I said, we are producing something which is not needed today, and which we are not producing something which is needed today. So ultimately, it also leads to shortages and surpluses. So we have high inventory, but along with that, we also have shortages and surpluses. Now, since there is a lot of WIP on the shop floor, so our lead time is a function of how much WIP is there on the shop floor. If the WIP is more, so any new order that will get into the queue will only come out as per its lead time, as the WIP which is prior to that order gets converted. So the lead time of the system increases significantly, which ultimately leads to very poor due dates performance. And we may try to take all the actions to maximize, but ultimately there is a pull from customer, there is a shouting from the customer, even top management, that why this order has not gone. So though we may have done setup, but ultimately we need to change, we need to keep frequently change our production schedule, and there are too many customer complaints. So are you with me till here?
Yes, we are with you.
Yes, very much.
Yes.
Great. So though we have kept a Q&A session at the end, but in case there is something, you can please always stop me and we can quickly discuss around it. Yeah. So what we have just learned is from this thing, that it is only the bottleneck which is deciding the capacity of the system. Rest of the processes which are upstream and the downstream to for the bottleneck are these non-bottleneck operations. They have more capacity. So only if we keep them producing, they will do nothing but create more inventory. So ultimately, what it means is, these non-bottleneck operations will be idle from time to time. So the assumption that we just saw is that a bottleneck resource standing idle is a waste is actually not true, right? Only the bottleneck resource which is supposed to operate at a full capacity, and that too if plant is the constraint. So in many companies we have seen that marketing orders are the constraint, that we do not have even enough orders to supply to the plant so that they can operate at full capacity. So in that case, we will, even bottleneck operation will not operate at full capacity. Somebody else joined.
Yeah, Nidish has joined.
Yeah, hi.
You continue. Yeah.
Yeah. So what we just learned is that the resource standing idle is not a waste. Uh, Ultimately, only bottleneck resource needs to be fully utilized, and the non-bottleneck operations will be idle from time to time. So what is more important is that if we want shorter lead time, if we want leaner inventories, if we want great delivery performance, material on the shop floor should move fast. So the flow of material, the speed at which the material moves at the shop floor, determines the how much or the in at what speed the material is coming out of the plant, right? So what we can conclude is that the primary objective of the production or the manufacturing is to manage flow of material, right? That it should ensure that the material flow through the bottleneck fast. The material doesn't stop at the shop floor, and it is available and shipped to the customer on time, right? So few learnings from here, that if we have to establish flow, right, we should abolish this local efficiency at the resource level. We have seen that in many companies, the productivity or the OEE measure is done at all the resources. Ideally, it should be done only at the bottleneck, because that is the process which is really supposed to operate at full capacity. That is why it is only meaningful to measure OEE at the bottleneck. And now we are saying that the non-bottlenecks should not operate fully. But what is the system, what is the mechanism that needs to be put in place, which guides the operation that now stop, do not produce, right? So, and if we have to really put a control to the plant and bring the predictability in the lead time, in the output, our full attempt should be to balance the flow, to improve the flow, and not get into the balancing the plant, because time and again we hear that ours is a balanced plant. So if the plant is balanced, what will happen is that then bottleneck is not fixed. Every day the bottleneck changes, the bottleneck changes, the output of the plant is uncertain, and all the symptoms that we just discussed reappear. So by design, the plant should be unbalanced. By design, we should choose our bottleneck process. Generally, in any plant, whatever is it's the core process or the most expensive equipment, generally is positioned as the bottleneck operation. So now, so we learned that instead of resource, material sitting idle on the shop floor should be a bother to us. So if we see that a material material is sitting idle on the shop floor, we should take all the actions and right decisions to ensure that the material flows through the system fast. So let's learn how we will do this, right? So in any business, typically we deal with multiple flows. So at the top would be idea flow, which is about how to take company forward. Then it is material flow, money flow, and the order flow. So today's agenda is to discuss around material flow, how to maximize this so that we can experience more output in shorter lead time with less inventory, right? So this is the 5-step process that Dr. Ellie Goldratt has given us, which is also called as process of ongoing improvement, which we also call as POOGI. So this is the method by which he has suggested that you can improve the flow of your plant by following this simple 5-step method. So step 1 is identify the system's constraint, right? So this is the primary thing. In absence of this, many companies waste their capacity because the focus is not there and we are not aware about the bottleneck. So our efforts is not to ensure that bottleneck runs full time. One simple indicator Dr. Goldratt has given is inventory. So the work center before which there is a lot of inventory pile up can indicate that, okay, this is the bottleneck operation for us. So primary step 1 would be to identify the bottleneck. What is the system's constraint? Now, most important thing aligned to what objective I had said in the beginning, to deliver more from the same system, right, without any investment. So it is about how to exploit the system constraint. So whatever bottleneck operation or constraint operation we have identified, first attempt should be that it should operate at full capacity. So what it means is we should find out all the reasons why the capacity of that operation gets wasted or why it is not performing. One of the primary concern in that is that material available to that work center is not available on time, apart from other reasons of breakdown and uh, worker not present. So material availability is the primary reason why we have seen that either the right material was not available or the bottleneck was waiting for some material to come. So that's why it would not work. And learning from that non-bottleneck operation should not operate full. So it should actually align its pace to the bottleneck operations, which is subordinate everything. We move to step 3, subordinate everything else to the above decision. Means all the work in the company should get aligned to how we need to feed the bottleneck operation in order to deliver the customer orders on time. Once we have mastered this set of identifying the constraint, exploiting it, subordinate the system should be able to deliver much more, and we should be able to extract maximum out of the system. Then only we should go for elevation. Many a times we have seen that companies have not exploited their constraint, but there is a belief that if we want to grow, we should invest. So, but ultimately what happens is any new investment or any new capacity that gets added also falls to the same tune of what we saw in step 2, that it is not really fully exploited. So let's say if the current exploitation level is 60%, so we may have thought that it will deliver 100, but ultimately it will deliver only 60. So that's why this step 1, 2, 3 is the primary thing which needs to be done. So in this endeavor, it may happen that the constraint gets broken, means the current operation or the process may not remain bottleneck, or even the operations may not remain bottleneck. So in that case, we need to again start with whether our constraint has shifted or it has moved to marketing. So the respective actions needs to be taken to get more orders. Right. So practically, we saw this step 1 to 3, right? So step 1 is identifying the constraint. So theory of TOC actually, in TOC, this terminology of drum buffer rope mechanism has been given to make it simplify and understand what does it practically means. So once you have identified the bottleneck, you can label it as drum, based on whose beat all the other processes in the company will operate. So as I said, materials.
Ayush, time check. We are already 35 minutes into the session.
Yeah. So so buffers. So we said that buffers should be there, or the material should be there timely. We should protect the bottleneck of resource. So for any shortage of material or weight of the material, so we should protect. So buffer mechanism has been given to protect the bottlenecks OEE or the performance or the utilization in absence against the shortage of material, right? Now, step 3, subordinate. So that third mechanism is called rope. It ensures that it chokes the release of material on the shop floor. Basically, it governs when do we really release the material on the shop floor, which ultimately determines and ensures that the WIP on the shop floor is less, bottleneck gets the right material, and the non-bottleneck machines do not work time to time, and it only aligns with the bottleneck operation. So with this thought, I want to move at a different way of looking. Earlier, we had looked at the resource-centric view. Now, from the materials flow perspective, there is a different way of looking at this. If we look at any plant in this world, right, it would be a combination of one of these plants or one or more of these plants. So which has been labeled as VATI, VATI. So V type of plant, A type of plant, T type of plant, and I. What is V type of plant? The typical characteristics is that it looks like V, At the bottom, there are few raw materials which ultimately can get converted into multiple semi-finished goods, and at the end there is a huge variety of finished goods. So that's the typical way the material flow happens in a V type of plant. Any steel industry, textiles industry is like a V type of plant where the raw materials are few, but the end products are huge. So the most important problem that this type of plant encounters is stealing. Basically, there is a divergent point. One material can get converted into another product. So if I convert into product one and the demand comes for product two, there is no way back. It is converted. So if the order comes for product two, then I will not be able to serve this, right? So it also highlights or gives a cue of how do we manage this plant. So the way to manage this plant is to hold more material at raw material level and less material at finished good level, because typically what we have seen in companies is there is a monthly plan made which becomes a commitment, or the forecast is given from the sales team which becomes a commitment for the plant. Entire production plan for the month is made, material is committed to the respective products, but we know that forecast is never right. We may have produced a product A more, but the demand came less, and product B less, but the demand came for more. So ultimately, we get left with inventory or suffer loss of sale as well, right? Second type of plant we have seen is A type of plant, which is nothing but it's a many sub-assemblies finally making a one product. So any special projects, aircraft, ship, would fall under a category of A plant. The most important thing or the key to manage this plant is synchronization of material at the converging lines. So if all the material is available for assembly, then only this assembly can happen and we can ship the product to the plant. Even if one screw is missing, we can't complete the assembly, we can't complete the system and ship. Now, T plant typically is a kind of considered as one of the most complex plant because it's a combination of A and B plant. So it has both elements wherein one component is going into many products and many components are going into one. So it's typically again an assembly plant like motors, computers. So here we face challenges of both synchronization and stealing. And last, we have this I type of plant, which is a kind of dedicated lines and where so that only set process is there and the material gets converted into finished products. Now, we said that we need to understand what is the supply chain design we should do. So the key questions that needs to be answered is, where to keep inventory, where to keep what to keep in inventory, and how much to keep in inventory, right? So this is the direction for the V type of plant. We said that V type of plant, there are raw materials and that gets converted into finished good. So we can decide on are there any products which needs to be buffered, right? And are there any products, rest of the products which will be made back to back as per make to order. So these are the products MTA, make to availability, will be the items which we will keep in finished goods. They will be backed by semi-finished goods inventory because there is a divergent point V happening from the same SFG. I can make many finished goods. Even some of the MTOs also get served from SFG. And at the end, at the base is the raw material buffer, which is the key and primary buffer, so that whichever order comes, it can fulfill the respective order. If it is an MTA product, so the characteristics of MTA is FG is always available, which is backed by the raw material and RM buffer. So as the FG gets sold, the respective finished good gets replenished, and which is again replenished at SFG and RM level. Make to order will be back to back. So as the order comes, we either have the readiness of raw material or not. So depending on that, the material will get shipped. Typically, A type of plant and T type of plant are the assembly plants. So here the components availability is the key. But still, we have seen many plants where finished good products also are required by the customer in short lead times. So major of the buffer would be at components level. Wherever we will not keep the inventory, there is a we can serve the some products in very short lead time by having a components buffer, which typically falls under assemble to order bucket, so that whenever the order will come in a very short lead time, we can withdraw the components from the buffer, convert it into finished goods, and dispatch and make to order will be back to back. So this is how the we can configure A and T type of plant. Second question was what to keep in inventory. So we know that in our product portfolio, there are some products which gives us highest of our throughput or sales. Then there are little longer range of product which gives us some medium throughput or sales. And there is a long lag of tail of products which gives us very less throughput. So we all have heard about Pareto, right? 80-20. So we slightly use a slightly modified version of Pareto, which we call as head, body, tail. So head is on 50% of the contribution. The products which we contribute to 50%, body 40%, tail at 10%. Same will be true for the customers also, right? That few customers gives us majority of our business. So we can do this analysis and study our products, our semi-finished goods, our raw material based on the sales, consumption, GRN data. We can look at what throughput they have contributed, what sales value they have contributed, also based on quantity. We can do this head, body, tail, which gives us clear indication. And that can be done based on either historical data. Many times historical data is not representative, so we can use projections, or it can be used as a blend of both. So which will give a clear idea that which are those products which should be buffered, which should be buffered at finished good, which should be buffered at semi-finished goods or components, and what should be buffered only at RM. And frequency.
Rajiv wants to ask something, I guess.
Yeah, sure. Hi, Rajiv. Yeah, tell me.
Yeah. Okay, Ayush, can you please go back by one slide?
Yes, please.
No, not this. Next one.
This one?
No. Again, yeah, this. Okay, head, body. You said.
Yes.
So I did not understand the relation between whether it is head or middle or long tail and the level of inventory.
So this is about this is about what we should keep in inventory, because well, should we keep finished goods in inventory based on the type of flow that we discussed? That if we have to deliver significantly high performance, delivery performance, and also keep inventory low. So first of all, here we discuss that where we should keep the inventory. So this helps us to understand in order to solutionize the V type, A type, and T type of plant. Where we should keep inventory, finished goods, semi-finished good, RM. Now within semi-finished goods, within finished goods, within RM, what we should buffer, head, body, tail analysis helps us to understand that which are those products, which are those customers we should serve, give priority and serve with a high service level. Should we make it available as product, make to availability? If customer ready to wait, so should I buffer at SFG level? If customer is ready to wait further, will buffering at raw material level will be enough? Or if it's a pure MTO, then I may not even buffer at raw material level. So as and when the order will come, I will. So this is to help take the decisions of what to keep in inventory, what we should keep in inventory in order to support the high service levels and sales. Did I answer your question?
Okay, I got it. Thank you.
Yeah.
So
next question, you mentioned inventory, so that's the next thing. So most important question or the tussle that companies struggle with: how much inventory to keep? Should we keep high inventory? Should we keep low inventory? Because if we keep high, our cost will go up. If we keep low, we may incur sales loss. So this is the way to calculate the how much inventory we should have in the system. So it is a combination of your rate of sale or consumption multiplied by the replenishment lead time. So replenishment lead time is from the time a consumption or sale happens to the time we put it back in the inventory is the replenishment lead time. And we know that rate of consumption keeps on changing. Sometimes it's high, sometimes it's low. Replenishment lead time also changes. Sometimes our production lead time or the time we get from the raw material from the suppliers, it also changes, right? Sometimes we get in less time, sometimes we get in more. Is there a question?
Yeah, Rajiv.
Yeah, Rajiv.
May I?
No, you have
Yes.
raised hand.
Yeah. Well, please correct me if I'm wrong. What
Yeah.
I remember is what Godred has said,
Yeah.
that you should be keeping this calculation is maximum consumption within average replacement time multiplied by factor of safety. So it's not rate of consumption, but maximum consumption multiplied by
So,
average replacement.
Rajiv, you have to be approximately right.
So
we
Rajiv,
can-
yeah,
we can take
so
anything.
approximately right. Plus, what we have seen is now, if you see in any company, the variability in demand is very high, right? There is no sense pattern. You can say sometimes it's 5 quantity, some next day it will come as 500. So if we go and try to keep the inventory based on the highest order that we receive, and we know how the orders are driven, right? Based on the targets that are given or fear of unavailability. So we get a lot of spikes. So if we try to keep the inventory based on the highest order that we received in the past, we will end up carrying a lot of inventory across the year. And probably it will not be
So
the right
here,
thing.
what Dr. Godred has said, that it is within the replenishment time.
I'm
The
talking about within
replenishment
replenishment
is
time
1
only.
month. So consider, highest sale during 1 month. So as you progress, it will change. And
Yeah.
he has set the rules also as to when to change the inventory levels.
Yeah.
So,
Okay,
so,
sorry.
so all those
Go ahead.
things have been updated if we go by DDMRP, which is what Ayush is attempting to communicate.
Okay. I need to learn that. I don't know enough about it. Thank you.
So this is the way the buffers can be set. So one of the critical element is to bring priority, because one of the common problem that we face in any company is the priority is not common. So this is the way to bring the priority in picture. So the way it is done is, let's say you decided to keep a buffer of the item as 90. So you can do it 1/3, 1/3, 1/3. So up to 30 is green, red zone, up to 60 is yellow. This is green zone. If your stock is 0, means stock out, consider it as black. Between up to 30 is red, up to yellow is up to 60 is yellow zone, and green zone and white. So now these are for buffered part where we are keeping the physical inventory. Yeah. Any question?
How much?
Okay. For non-buffered part, it will be time based. So let's say an order has come which has to be delivered by 9th October and its lead time is 9 days. So we can do 1/3, 1/3, 1/3. So if we see that today is 29th September, that order will be shown as white. On 1st, it will turn green. For 3 days, it will be green. For next 3 days, it will be yellow. And last 3 days, it will be red. If we see that on 10th, this order is not delivered or received from the supplier, it turns black. So this attaches priority to the item order, and accordingly our actions of expediting and ensuring that the material is delivered to the customer on time happens. So probably I'll skip this exercise. We will move to the last part, which I wanted to showcase about mechanism as well as actual working that a system that we have developed and we use and implement at different clients in all our implementations, right? So typically the question in the supply chain starts like this. The salesperson will have the curiosity of, do we have the stock? Do we, when can I take a sales order? When can I commit a date? If the order has been taken, what is the status of my order? What material is ready for dispatch, right? Planning and production will go into that. What is the inventory in the system against the demand, stock and WIP, so that they know what more to produce, in what priority. related to subordination, when should the raw material be released on the shop floor, right? Full kit is very important, that I want to produce, system is saying I should produce, whether I have the raw material or the components required to produce it, that visibility comes very handy. uh, Last is for purchase, that how much, because their job is to make the material available to the production people in time so that they can deliver the material on time to the customers. So how much inventory is there in the system, their stock, open orders, what and how much they should procure, in what priority, which orders they should follow up from the vendors in what priority, becomes a primary question. So this is how ultimately it becomes the structure in which a planning system or the it gets designed in order to deliver high on time in full, reduced inventory, and shorter lead times. So there are daily inputs that gets taken. So, one is demand, on-hand stock, production orders, purchase orders. There are master inputs like what is the bill of material, method of manufacturing, and finally the output of what to produce, what to procure, what is the priority, full kit is there or not, and what to dispatch. So I will switch to the Excel sheet that I wanted to quickly demo. So this is the typically a planning system that we put in place at any client. It's an Excel-based system which has a series of steps which help the person runs the planning system daily. So generally it takes once the data is available, generally it takes 10 to 15 minutes to do with the away with the planning. So once the planning is done, most of the time, 90% of the time, team can really spend on execution, because what we have observed is, because of in absence of the right system, lot of time gets spent in planning and very less time is really spent or left for execution. So as I said, data around what is the open demand, what is the inventory today, what is the WIP, gets absorbed as input, and then the planning system is run and it throws the respective outputs. So output number one is that yes, we took orders. What is the status of my orders against the? Let's compare it with what we said. That what are the typical questions gets asked in the supply chain and what are the answers we want, right? So it gives a quick visibility around what is the readiness of my order, what material is available against my order, right? Then we said around planning. So we set the buffers. Let's once the design decision gets take place, what we will keep in finished goods, so make to availability. So all that data is input here, which tells that this is the item I want to keep in buffer, and this is the buffer level that I want to define for. So every day on a daily basis, system takes input of what is my stock, what is my WIP. Now, more important thing, maybe Rajiv, this will answer your question as well. The kind of the whole objective is to deliver more by keeping less inventory, and we know that variability is very high, so difficult to incorporate a spike while calculating buffer. But the system does handle if there is any spike separately, so that system will plan for that order. Because if we try to supply a large order from our small buffer, it will go stock out. Many a times there are backlog in the system. But as soon as it opens, it may have been because of credit lock or different reasons. As soon as it happens, it washes out our inventory. So system needs to plan for any backlog or any large order separately, so that system not only serves our past demand, but also ensures that the availability of buffer is there to serve any future orders, and also incorporates any large order which comes in the system. So a mechanism is built to keep on sensing these large orders timely, so that we get enough time to produce them and supply. So every day, based on what is my availability at different products, system throws up what is my status. As we discussed, stock out is black, up to 1/3 is red, up to 2/3 is yellow, up to 2/3 is yellow, up to top of buffer green is green, And if the inventory is more than the buffer, it is considered as excess, which is treated as white. So similarly, if the decision gets taken at SFG level or raw material level, it gets planned in the similar fashion. So what we do is generally we quickly create a dashboard which is highlights the health of the system that we are trying to manage, right? And it is a very important feed for the top management to have a quick review of what's happening. So it throws about that for the finished products, what is my availability of products? How many are blacks, reds, yellow, green? Similarly, at SFG or the raw material level, it also highlights my sales order status. So based on the time buffer that we discussed, it keeps on highlighting how many sales orders are running late, how many are in red, yellow, green, and whites. So that gives a very quick handle on and visibility around what is the how is the health of my system. So finally, once the planning system is run, system gives output in terms of so here we discuss about only buffered parts, but we have orders of non-buffered items as well. So system will finally combine the entire output and bring in one place, which helps the team to guide that in what priority they should release the job card on the shop floor. System also has the capability to monitor the load on the bottleneck, because we said that's the utmost important thing, that how much load is there on the bottleneck, so that I can decide whether I should release a new job card or not. And once though the job card flows, visibility at different operations also becomes important. I'll not say planning, but visibility, that whatever work is coming their way, in what sequence they should execute. So respective operations sheet also gets made, which highlights that how individual operations needs to execute based on, but the real planning only happens as per the bottleneck load and what needs to be executed at the bottleneck. So this is the
yeah. We have run out of time, but people are okay to continue.
Yeah, so maybe 5 more minutes we will extend, and then we can take
available. So can you put in the chat box how long it is okay for extension? Quickly. Because many people have logged out actually.
Okay.
So Praveen, Rajiv, Sharad. Half an hour is okay. Yeah.
Okay. So most important thing, as we said, that load visibility on the bottleneck becomes primary information based on which the entire system governs. So at the bottleneck operation, we system also has the capability to bring in the load visibility, that whatever current work is there, released, unreleased, how many days the bottleneck operation or the constraint process is occupied. This helps in 2 ways. It also brings visibility of how much our resources are loaded. Second, in order to take a new order and commit the date, we discussed that, right? This is the first question of the sales team, that there is an order coming, when I can commit the safe delivery date. So based on the load on the system, on our constraint, we can safely commit that any new order that will come in will fall in queue, and finally we'll be able to deliver on this particular date. So so this entire end-to-end planning, from the time an order has come in to the time it goes out, what sales dispatch team will do, what planning team will do, what production will do, what purchase will do. So that clarity this planning system brings in on a daily basis, what to do daily and in what sequence. So that aligns with the actual customer orders and market demand, and our service levels, on-time delivery performance improves significantly, and also the lead times get shortened. And in this entire process, because now we are consciously running the system, we have defined how much inventory should be there. So overall inventory in the system also gets down, because we have seen that in many environments, despite wanting not to keep inventory, they have loads of inventory, 3 months, 4 months of inventory. So by design, this system ensures that overall methodology ensures that the inventory in the system is controlled. WIP at RM level, at FG level, definitely, and most importantly at the WIP level, so that our working capital or our investment is limited, which ensure that the flow is faster and the throughput realized through the system is maximum. So I'll fall back to the slides. So I wanted to share some of the quick turnarounds that we have done. So for B type of plant, we have worked with a blow molding company, wherein they were having they were falling short of capacity. They wanted to invest more so that they can deliver more. But what we saw is that once this was implemented, a lot of almost 35% additional capacity was released, which is equivalent to a respective number of more machines, bottleneck machines they had bought, right? So their lead times crashed, their on time in full improved significantly, and the inventory turns increased from 6 to 8. Example of A type of plant that we have done. This company is into printing machines manufacturing. So they were at a stage wherein they were about to infuse capital because they always had order backlog, and they were falling short of capacity. So once this concept was implemented, they uncovered almost more than 100% hidden capacity. So in 2 years' time, they actually started doing double from the same investment, and their lead time significantly crashed from 4 to 5 months to 6 to 8 weeks, and in the process, inventory also came down. This is an example of one of the company which was T type of plant. It was into manufacturing of pumps and motors. So again, they had orders. They had a opportunity to supply more orders provided they were able to supply. Once it was implemented at their end, so they also uncovered almost 100% capacity. So within a few weeks time, their output doubled actually, and their on time in full significantly improved from 30 to 85%. So typically, Yagna follows the method. This is the approach of Yagna in terms of putting the method in place, coupled with supporting measures, because measurements drive behavior of people. So if we want to put the right method in place, supporting measures also comes into picture. And what is more important is how do we review business, how frequently we review business, what do we measure, what questions we ask. So that gets instituted by a scorecard which we put in place, which gets reviewed every week. So what it does is it provides 52 opportunities in a year to understand where are we vis-a-vis where we want to go and do the course correction. Typically, this is a engagement model that Yagna has. So today's call was predominantly around awareness, so that we can create awareness that theory of constraints concept exists, and it has helped many companies in the not only in India but across globe, and it can help you. But in order to understand how it will apply at your end, how it will work for you, what benefit it can deliver for you, there is a step which we offer as assessment. It's a paid exercise, which is nothing but a business diagnostic, which highlights quick current reality of the business, what challenges companies face, what are the typical problems are there, what is the root cause, what few changes that needs to be done to unlock the potential. And finally, it goes to the actual implementing the steps and turning around the company. So that's the phase called adoption. So these are some of the clients that we have implemented in last 7 years. Prior to founding Yagna, we had worked with larger companies as well and turned around them significantly. So these are few names. So myself, Deepak, Anirudh, we jointly created Yagna, and with the whole aim of helping manufacturing companies to realize their full potential, basically to maximize their ROI from the same investment. So I would recommend, if you have already not read, I would recommend this the book called Gold, which was written by Dr. Ellie Goldratt, who is also the father of Theory of Constraints, and a very interesting article which is called Standing on the Shoulders of Giants. It gives a very different perspective and clarity about theory of constraints, and also highlights how it gets built up based on the previous approaches, as well as supports the current supply chain complexity. So in case any questions, I'll be happy to discuss, and maybe even after this session, in case there are questions which remains unanswered, you can call me, you can mail us, we'll be happy to discuss. Yep. So any questions?
Hi, sir. Good evening. This is Muthu here.
Yeah, hi Mukul.
So I'm from Featherlight. So
Okay.
we are into furniture manufacturing.
Yeah.
So now currently we are actually setting up a new factory. So
Okay.
I'm currently handling the chair division. We manufacture office chairs.
Okay.
We are setting up a new factory where we will be manufacturing workstations and tables.
Yes.
So this is for education units. So education system, normally how it works is, see, they get their budgets in the month of December or something, and December, Jan. So when the next academic year starts, and
Yeah.
the entire year's workload is going to be pressurized in the 3 to 4 months.
Yes. Yes.
So if that is the case, how do we set up the capacity? See, overall 12 months is going to be in the next 4 months, and other months will be going to be like vacuum.
Correct. So in this case, whatever is your annual plan, your capacity has to be annual demand that we are anticipating, or what is the market we are looking at. Our overall capacity has to be more than that, because system must always have a protective capacity, right?
Okay.
Now, since you said that our majority of the sale happens in 3 to 4 months, and typically this happens in many businesses like fertilizers, right, where the window in which we can sell is very limited. Correct. So in this case, what typically happens is a build-up of inventory is required. So we know that. So one thing companies does is pre-build the everything, and then try to sell it over the selling period. And again, we push inventory and at the point of sale location. Now, again, forecast is never right. We end up with a lot of shortages and surpluses. So right way to do is,
But
yeah, please.
sorry to interrupt. One challenge here I have is, this is not a standard product.
Yeah.
So this is going to be a customized product with respect to the environment of customer, schools.
But these are confirmed orders you are saying, or we are anticipating variability?
It will be coming across one by one during the year.
That I understand. My question is that the orders which you are talking about, which will be supplied in 3 to 4 months, are these firm orders, or these are?
No, the orders itself is going to be picked up only during February to say March.
That's fine.
March.
But are these firm orders, or will we are anticipating any change?
No, it'll be firm orders, but we have to dispatch it within, say, next 3 months, like that. The entire orders.
So if it is a firm order, then it's in a way it is back to back MTO. Then it's not that availability will create any difference, right? It's an MTO environment, wherein you have your annual capacity should be much more, more, at least 20% more than the overall demand that you are anticipating, right? Number one. Second is, as the season ends, I think this activity of building up the inventory will start, if that's the way your capacity is defined. If your capacity is much more than what the demand you are anticipating, then you will have to decide that when we should start building the inventory as per the lead times. And accordingly, so as a function of your capacity and the demand, the start of the built up of inventory needs to be decided, and accordingly ensure that by this entire planning system which I talked about, because one element is replenishment, another element is MTO. So how this brings in the visibility of ensuring that what orders demand we are chasing, when should we start producing, what is needed to produce, whether it is available or not, right? All that comes into picture, and the system helps you deliver, produce on time, and helps deliver on time. So that's what.
Okay. This Excel sheet which you share, I think, will it be of any support for us? Which you're explaining? Will
Yes,
be supportive for us
this
to
kind
create
of.
some.
So again, as I said, there are different environments. It will be a combination of VATI plant. So unique to each company, respective planning engine gets created, which ultimately supports the kind of flow that you are and the challenges in the supply chain you are encountering.
Ours will be more of a V type plant.
Yeah. So in that case, all the configuration decisions, the design of the supply chain, what do we keep inventory? Do we bring it back to back? Right. So all that decisions gets configured. What is the lead time either for production or for procurement, so that the respective indications, order recommendations, as well as the priority keeps coming. So, so my answer is yes. So the MTO version of this planning, pure MTO version of this planning engine, in case there is no inventory that needs to be planned, will work. Maybe inventory at raw material needs to be defined, because if there are some certain repetitive material, as I said, head, body, tail will throw us the light in terms of what inventory we can keep, because not every material or every order needs to be chased back to back, right? If there is a consistency in usage, we can buffer them and take advantage of low variability and low inventory. And also I had prepared, so maybe it is not, since you mentioned that it is a purely MTO environment, may not be of use. So I wanted to actually, I created a small sample planning sheet which supports the buffer levels. So here you can decide on what products to buffer. So system, you can input what is your demand, what is your stock, what is your WIP, what is your open PO, and related to finished good products, you define how much buffer needs to be kept based on the logic that we discussed. System will keep on reading how much inventory is there in the system, how much WIP is there. So ultimately it brings out what is my priority, in which priority I should chase, in which orders are getting late, which material is getting stock out, right? Or respective order recommendation, appreciating the batch size, because batch size also is a reality today, provided the variety and the volume which is there, and the consideration of setups, manufacturing. Similarly, raw material again can be configured, what raw materials we want to buffer. System will keep on reading what is its stock today, what is open PO, and it will throw out priority and order recommendation in multiples of considering the MOQ decisions. So ultimately, at a very simple level, system can start showing you that all the orders which I have for the respective, from the customer for the respective products, it has a delivery date attached. So how much, what is the status today? How many days are remaining? So one can quickly run the show with a tap on what's the inventory, what is my system's health, that by knowing it quickly, what is my sales order status, what is my MTA availability, what is my PT raw material availability. So that's a Excel sheet I wanted to give away, so that you can use it, experiment it with, and see if you find it useful, so that it can be enhanced in the next steps.
Sure, fine. I think it will be supportive. Thank you, sir.
So Muthu, which ERP is Featherlight using?
We use Business Central, Microsoft Business Central.
Okay. And do you run MRP in Business Central?
No, we don't run MRP.
So you have all Excel sheets all over the place.
Yes, most of the case we do it in Excel.
Okay.
Currently, see, this is actually a new business I am taking up now. So I just wanted to see how this will be supportive.
Yeah,
so that's why I joined this session, because in ad division was different. So TOC support us a lot. So I have gone through some TOC principles, so it supports us a lot. But this is a different ball game altogether. So just want expert advice.
So who has helped you implement TOC in the chair division?
I did it myself.
Wow.
I
Fantastic.
learned it and I did it myself by saying things.
Okay.
Great.
So what are the inventory turns now for Featherlight chair division?
So actually, inventory has come down. Our sales, if you see, in the last 3-4 years, from 100 crores, we are now at 331. This
Okay.
year, we are targeting 370
Okay.
in chair division.
Uh-huh.
So
But
this
how
is
much
it.
inventory do you have to maintain in the system?
So earlier, we were, when we were doing 100 crores, we had an inventory of 27 crores. Now we are 25 crores.
Super. Very nice.
So this we have done. So this is the thing which we are.
Mm-hmm. Great. So maybe you can invite us for an assessment.
Yeah, I'll get in touch with you offline.
Yeah.
I'll get your contact details. I'll get in touch with you.
Yeah.
Yes,
Yeah. Thank you.
that would be great.
Yeah.
Anybody?
Thank you.
Any questions?
Rajiv, any detailed
Yeah,
questions? Praveen?
I don't have any
No,
questions.
no question
I
from-
wanted to thank for holding such sessions. I wish that more people like Muthu should have joined,
Hmm.
so that there would have been more discussion on their problems and
Yes.
how you guys can really help them out.
Hmm.
I
Yes.
found that Muthu's problem is something very interesting because he has demand
Yes.
only for 3 to 4 months in a year.
Yeah.
So how much capacity he should keep, and what should he do with the capacity during next 8 months? I think he has found the answer to this question by himself and grown from 100 crores to 331 crores. Hats off to you, Muthu. He has done on his own. It's something simply great, and this gives me confidence in saying that TOC is simple. Yes, it is. So it is difficult to implement. That's why consultants are required. But I think Muthu has even overcome that barrier. Great, Muthu.
Yeah.
Congratulations. And Ayush,
Yes.
I wanted, I have seen you after a long time. If you remember, we had traveled from Mumbai to Pune, and I had the opportunity to talk to you all you guys. We had a day-long discussion, and I really enjoyed
That's
that.
why I was very happy when you had accepted the invite. So I saw that, and I was very happy that Rajiv will be joining. And after a long time, we will connect. So it's a pleasure.
Yeah. So I was very keen on seeing you again. I said, I come to Pune from
No,
time
I am
to
in
time.
Mumbai. I am in Mumbai.
Oh, yes, I know. I know you said Borivali, right?
Dahi
I
sir.
remember it.
I put up in Dahi, sir. Yeah. So Deepak
Dahi,
and Anirudh put up in Pune.
Yeah, I know. So
Yeah.
we had a great time.
I'll make sure
And-
that I'll meet you. It will be really helpful and
Yeah, we can meet. We can meet. I like you people, Yagna guys. Yeah, I had very high regards for all you. Earlier there was a
Same here.
session by.
same here. We read all your material that you keep on publishing. Your
I hardly
posts.
published though. Yeah.
No, but we have bought complete bundle.
No, that is Rajiv sir. That is a hint that we enjoy your publications, but I mean for last 1 year it has drastically reduced. So please.
Yeah, unless I find something new, or see, there needs to be some inspiration before I could write. I just don't want to write for the sake of writing here.
Hmm.
I agree.
So fine, it's okay. And I enjoyed talking to you also, Praveen. And if you remember, we had those days when we used to have online sessions and we used to discuss a lot. So if Yagna is starting something like that, it would be really very interesting.
So Rajiv, like you had asked for DDMRP session,
Yeah.
you tell me the date, we'll schedule it because all the
Yeah.
But
material
it's
is
not
ready.
me, it's not my date because I didn't find too many people saying yes.
Hmm.
Only 4 or 5 guys have said. So
Mhm.
maybe we'll have to advertise it on LinkedIn and get
Yeah.
good enough people here. Otherwise, I will
Correct.
come there, sit at ये करता हूँ, आपके पाँव के पास बैठ के सीख जाऊंगा.
Arre, we are all students. We are all standing on the shoulders of giants.
Yeah. So we said that from somewhere we should begin because this is one thing which was lacking on our side. So he said, let's begin from somewhere and gradually we will build up.
Yeah, you will, I'm sure. And it takes a lot of effort, a lot of pain. I've gone through myself of doing that. Though, okay, my presentations were not as great as you guys, but it was it is very interesting because every time, why I have attend Yagna session, because I believe every time I'll pick up something new.
Yeah.
So you give me okay, something to think. Now the problem that Muthu has put up, okay, it has given me some food for thought. How this can be managed, I don't know. Right now, I don't have answer, and I
So
didn't
we'll have to
understand
break down the problem and figure out if we have one client which is in the same space. They are based in Indore, Bonton Solutions. Muthu, you would be knowing them.
Yeah,
Who?
actually, this is the second company I'm facing the same issue. Earlier, I worked with Harita
Okay.
Harita Settings.
Settings.
It's currently Minda Group.
Ah,
We have set up a plant in Dharwad
okay.
to supply to Tata Marco Polo.
Okay.
So Marco Polo manufactures buses for schools, basically.
Yes.
So school buses, same business. So when we are supplying bus seats to them, their demand will peak from Jan to almost April. After that,
Okay.
where we do 2 crores per month, we used to do just 10 lakhs, 20 lakhs per month. The resource is what we do. We have to close the plant. Like that, it went to the situation.
Wow.
Now we have to find out a solution. That's why I just thought, okay, where I can get some idea.
So some we can definitely work together on this and figure out. See, we have dealt with this kind of extreme seasonality for agricultural input companies. So we have worked with a two pesticide companies, and they have similar things. So they also have to pre-build inventory before monsoon, and during 3 months of monsoon, they have to sell everything. And that too, monsoon varies from one part of the country to another part of country. So the sale peaks in Punjab in a different month compared to say Tamil Nadu. So they have to do that distribution planning also for the season.
But I think this case Muthu's case is different than what you had just described. I don't know, you know it better.
No,
This
because this
fertilizer
is
could be,
customized.
or the MTA kind of thing. And Muthu is having a problem that okay,
It is MTO, yes.
MTO.
Yes.
So the things are different.
Yes.
Maybe
I agree.
I know you are genius enough to find the right solution even for Muthu also.
No, we can attempt.
Yeah, of
And
course.
it has to be, so basically we say, like Goldratt says and Kazal Patak says, you have to start somewhere which is approximately right and keep on refining.
Absolutely.
So we jump and start, and then it gets refined over a period of time.
Yes,
So this Excel also, the first Excel that I and Ayush developed was in year 2012 for a company called Forbes Engineering. And over a period of time, so the dashboard that you saw was in the first version also, but the remaining Excel sheet has evolved a lot over a period of time.
Yeah.
And
That's
we have
great.
tried to make it foolproof that the lowest person in the department should be able to run from ERP. So all automation of calculations, everything. So they just have to copy and paste in the input sheets, and everything, all the calculations are done by the engine.
I think this is fantastic. What you are doing, hats off to you guys. Fantastic.
Only we have to
Because
sell more.
Rajiv, what we have seen is that we can give a lot of theory and conduct sessions for the client, but ultimately, once the different decisions are taken, they need something concrete to work with. They need on a daily basis what they should do, how it will actually translate into their working is what they need. So that's what over the time we have learned that this helps. And once it is done, it improves the flow really fast.
Yeah, but I was wondering, your DD MRP must be having their own software, right?
Yes.
Or they also work on your Excel.
Yes.
Would you recommend that software or that is very expensive?
So there are two things. One is first we recommend that let's understand. It's like this, that what ERP we should use, right? So ultimately, what system, what are the business rules, all that are there. So first we suggest that let's do the iteration in Excel and understand that how system will work for you. And then once there is a clear understanding, we translate this into IT system and support it through system. Because initially, just going to buy system, we face a lot of challenges in terms of data, in terms of missing processes. So what we have seen is the Excel gives us a head start. In 3 to 6 months time, it gets matured, and then migration to a software becomes really, because they are now used to that working, and it's just shifting the place that earlier you were doing in Excel, now you are doing in system. So that helps.
Right. That's great.
But you are right. In India, very few people are ready to invest in a software, and that too because it is a long-term commitment. Annual, it's the company that you have tied up with.
People have burnt their fingers. If you see the investments in the ERPs, at one point of time it was very expensive. So people had done that and then they didn't get the result of the results. So probably that could be the reason. I don't know.
Yeah. So, but we have sold to large company as well as even small company. 100 crore company also is using IntuiFlow.
Yeah, that is great.
Yeah.
Chala, we'll take.
Sir, can you just share me the Excel sheet so that they can just have a better understanding?
I will share with you. So I will mail it to everyone. So if you can ping me your mail address, it will help me.
Yeah, I'll text you now.
Sure. Thank you, everyone. Thank you for joining. Pleasure to have you all, and thank you for coming, taking out time.
And we look forward to more sessions.
Pardon?
Yes, definitely.
We look forward to more sessions.
Yes, we will. We will. So this was only starting. So we thought, let's touch upon one topic, and we will do it more.
Thank you very much.
Take care. Bye.
Thank you very much. Thank you.
Ayuji, thank you for your session. Okay.
Have a good day.
Yeah.
Thank you.
sir.
Thank you, Mr. Praveen. Really happy that you were able to join and spend good time with us, so that
Yes.
it gives us more confidence.
Thank you.
Yes.
Thank you, Mr. Mothu. Thank you,
Thank
Rajiv. Thank you very much. Thank you, everyone. Bye.